So, lesson 3 of Demystifying compilers will continue the lesson that we started last week for this series. We will explore now two issues on grammars and show how we can prepare a grammar to be used by some of the algorithms that we will explore on future lessons. This is the channel Bits em Alta Velocidade, that is in English Bits in High Speed. So on the previous lesson we saw how to produce a grammar for a programming language, and we intuitively recognize an input stream of code as belonging or not to the programming language of that grammar. Nevertheless, when we investigate algorithms for implementing this intuition of recognition, some relevant issues arise. We are now going to investigate some of them. The first issue is what we call ambiguous grammars. A grammar is said to be ambiguous if for some token stream there is more than one leftmost manner to derive it. In other words, if we necessarily derive the leftmost non-terminal for each step of derivation, and there is more than one manner to derive that token stream, then the grammar is ambiguous. Let's rescue part of the grammar for the subset of Java for which we specify these expressions. So, as we see on the next slide, this grammar is ambiguous. We'll show that by giving two leftmost derivations for string num plus num multiplied by num. So, in the first derivation, we derive expression EXPR non-terminal twice and obtain expression EXPR plus EXPR multiplied by EXPR, and then individually derive num always on the leftmost EXPR. On the other derivation, we derive expression once, EXPR once, and then reach num for eliminating the first leftmost EXPR non-terminal, and then derive another num on the next leftmost EXPR, and then another num on the remaining leftmost EXPR. So we can eliminate ambiguity by rewriting the grammar such that its left recursion is removed, that is, such that there are no non-terminals preceding the leftmost terminal, and such that we determine the precedence for plus and multiplication operators in order to control the manners in which they can be derived. So a possible non-ambiguous grammar for EXPR is the following. So is this one. So what we did here was to rewrite the grammar such that there was no ambiguity. This was achieved by not allowing more than one occurrence of a same non-terminal on any production of the grammar. So the last issue that we'll talk about is that of LL1 grammars. A grammar is LL1 when it is possible to derive a path from it only seeing the current token of its token string. LL1 means that the tokens are scanned from the left to the right. This is the first L of LL1, and that they produce the leftmost derivation, the second L of LL1, of the input grammar. 1 is the number of tokens that the algorithm analyzes in order to decide what will be the chosen path of derivation. Another feature of LL1 grammars is that they are not ambiguous and they are suitable for predictive parsers that will be studied on future lessons. So the grammar for our subset of Java is not LL1, as we cannot determine, looking at its individual token, how to derive a path for it. But our unambiguous version of EXPR is in fact LL1. We know, for example, what is the path that we have to derive in order to reach the stream num plus num multiplied by num, only looking to a single token at a time. So looking at only the first num, we'll see this path here. This one here. This path here. So EXPR evolving to T EXPR2, that evolves to F T2 EXPR2, and so on, reaching the expected num on the derivation. We continue the derivation now considering token plus, and we go from production G2 F2 T2 EXPR2 to lambda T F2 T2 EXPR2, and so on, reaching num plus T EXPR2. The other nums can be derived seeing the path of the T EXPR2 step, and the multiplication token can be derived from the path that starts from F2 T2 EXPR2. So in this brief lesson we learned what is an ambiguous grammar, how to remove its ambiguity, and what is an LL1 grammar. These concepts will be useful for future lessons. So next part of this lesson we will see some top-down and bottom-up algorithms for passing token streams. So thank you very much, subscribe on the channel, like the video, push the little bell such that you receive notifications for my new videos. and make questions and suggestions on the comments.